So those quantum numbers that you read about really are just telling us where electrons are in the atom. The principal quantum number is telling us what energy level or how much energy the electron has. The second quantum number tells us the shape of that electron orbital. And the other two quantum numbers tell us the orientation around the axis and then the spin of the electron. Again, we are not focusing on these latter two quantum numbers. Now, the first quantum number is really easy to correlate to your periodic table. In fact, if you could go ahead and take out your periodic table, we're going to be taking a look at that over the course of this video. The principal quantum number is what energy level, and if you wanted to go ahead and write in, we know that the principal quantum number is defined by n, and on your periodic table, the principal quantum number correlates to what period we are referring to in the periodic table. So if you wrote those in, those are the principal quantum numbers or the energy levels. So for example, boron exists in the second energy level. Calcium exists in the fourth energy level. Now, what we end up finding out is Bohr was sort of right that electrons are at different energy levels, but within those energy levels, we've got some embedded qualities going on, and that's where the other quantum numbers come in, the S, P, D, and F, which we'll get to in a moment. If you remember from the textbook, oops, it won't let me do that. If you remember from the textbook, I'll just extend it down here, that whatever our quantum number is, it tells us how many orbitals are within that quantum number. So the number of orbitals within that quantum number, that's kind of how it gets embedded, is equal to the square of the quantum number. So if we're talking about energy level 1, we've got one orbital in that energy level. If we're talking about the second energy level, we've got 4 orbitals, and so on. The third energy level has 9 orbitals, and then the fourth energy level, oops, that's backwards, would have 16 orbitals, and within each orbital, there can exist 2 electrons, and this happens to refer to that fourth quantum number, that spin quantum number. But the number of electrons, there are 2 in each orbital, so we get a pattern of 2, 8, 18, and 32 for the first 4 orbitals, the first 4 energy levels in the periodic table. Now we're going to keep going and define, well, what does this orbital look like, and where are these 2 electrons, where are these 8 electrons, and so forth as we move through the periodic table. So Schrödinger said that the energy levels in an atom are nested together in order of increasing energy. So the first energy level, we define it as being a 1s level. The second energy level has 2 sublevels, including an s, a 2s, and a 2p. The third energy level has a 3s, a 3p, and a 3d. And then the fourth energy level has a 4s, 4p, 4d, and 4f energy levels. Again, we're going to keep referring back to your periodic table, so please have that out as we proceed through here. So where are these S, P, D, and F locations on the periodic table? Sometimes we refer to them as being blocks. And if you have a highlighter or maybe a colored pencil, you might want to write this in on your periodic table. Let's start with the simplest one, and that would be the S block. I'm just going to highlight it in yellow, that the S block includes hydrogen and helium, and then lithium, beryllium, and then this entire first 2 groups of the periodic table. That's what we call the S block. So if we have an element in that section, like calcium, its electrons fill up in the S block. Moving up in energy, we have the P block, and that would be this square, not really a square, but it looks like a square, in this section of the periodic table. So from boron over to neon and then all the way down. That's what we refer to as the p block. So elements in this section of the periodic table will fill up their p block electrons in that area. Moving up in energy, we have this entire middle section, and I'm just going to draw a red rectangle around it. Those are the d block elements. So their patterns are similar. Their patterns of electrons are similar. And then we have the bottom two rows. Now, before, when we talked about the construction of the periodic table, we said that those two rows are pulled out to save space. And that is true. But what's also interesting is that all of the elements in these two rows have similar patterns of electrons, and these are called the F block elements. So you should have those marked on your periodic table so you can easily find where an element is so we can determine its electron configuration. Now it gets a little more complicated than that because we have S block, P, D, and F block, and we're also going to add on to that principal quantum number, the main quantum number that we talked about earlier. And if we rewrite those in 1, 2, all the way down to 7, we get a little bit more detail about what energy level we're talking about. Now for S and P, it's really simple to find what level we're filling up. So if I were to go over here and circle phosphorus, we're filling up the third energy level, the P block. Or if I'm talking about krypton, we're filling up the fourth energy level in the P block. If we're talking about cesium, we're filling up the sixth energy level in the S block. So the S and P's are really simple. Now the D's and F's are a little tricky, so you need to pay really close attention. Because of the order of energy, the D's and the F's get numbered slightly differently. So scandium right here, element 21, is actually in the third energy level, fourth, fifth, sixth energy level. So for example, iron would be in the 3D block. Gold would be in the 5D block. The F block also gets numbered strangely in that this is the fourth energy level. The lanthanide series, that top row, is in the fourth energy level, and then the actinides are in the fifth energy level. So our favorite element right here, uranium, is actually filling up in the 5F block. Now, why do we start combining these together? Well, it really all has to do with energy, in that the more electrons we have, the further away we are getting from the nucleus, the more energy we have. And so one way to think about all of those numbers and letters that we just wrote in on the periodic table, that you could think of them as increasing energy as we move away from the nucleus. So the nucleus of that atom would be somewhere down here. And remember, that's like a small circular area. And then the electrons are somewhere out here, nested in their energy levels that are defined by their principal quantum number. That's the energy level. And then their magnetic quantum number. Okay, I'm sorry, their angular momentum quantum number with the letter, the shape of their orbital. Now what we need to keep talking about is, well, what do we do with all of these numbers? Well, what we're going to end up doing is we're going to be defining or writing out the electron configuration for different elements. I find this diagram to be useful, so you might want to find a similar one in your textbook, or I wouldn't copy this down, but you might want to refer to this later on.